Hey guys, let's review what we've done so far in chapter 1. So we're dealing with functions. So first, we're going to evaluate f of 10 for this function. F of x equals 3x squared minus 7x plus 1. And that means this 10 is going to get substituted in for all of the x's. So that's 3 times 10 squared minus 7 times 10 plus 1. So by order of operations, exponents comes first. The parentheses comes first, but there's nothing to do inside the parentheses. So we go to exponents, so that's 3 times 100, at 10 squared, minus, and we have done our exponents, so we can go on to multiplication and division if we want, 70 plus 1. So we get 300, and then we have minus 70 plus 1. One of the dangers is people like to just combine these two and say it's minus 71, but that's a negative 70 plus 1. So if we're going to do that right now, if we're going to combine these, we're going to have to do negative 70 plus 1, which is minus 69. But let's just do it in this order. Subtraction, addition and subtraction from left to right. 300 minus 70 is 230, plus 1 is 231. Okay, next we're doing g of n minus 5. That means n minus 5 goes in for that x. So that's 2 times n minus 5 squared minus 2. So that n minus 5 squared is n minus 5 times itself. Okay, and we could do the shortcut, first term squared, which is n squared. Double the product, negative 5 times n is negative 5n, double that is negative 10n. And then the last term squared is plus 25. Or we could distribute n squared, minus 5n minus 5n makes minus 10n, and then plus 25. Now we'll distribute that too. So it's 2n squared minus 20n plus 50 minus 2. And then I've got some like terms. 2n squared minus 20n plus 48. Define domain. The domain is the set of all inputs. If this had said range, then it would be the set of all outputs. If it said define function, it would be a relation in which every input has only one output. So those are some important words to remember. So domain, range, and function are all important words to remember. Does this graph represent a function? The answer is no, because there are some inputs with multiple outputs, and I can prove that by drawing a vertical line that touches the graph more than once. If you can draw a vertical line and it touches the graph more than once, then you're not looking at a function. What is the domain? So domain is left to right. It goes left forever. It does not go right forever. It only goes this far. And it doesn't even include this point right here. It gets infinitely close to an x value of 7, but it doesn't touch it. So for our domain, we'll say it's all x's that are less than, not equal to, so no underline, less than 7. If this was filled in, then it would be or equal to. But it's not filled in, so it's not equal to. The range. It goes up forever, it goes down forever. So it seems like all reals, except it can't be a y value of negative 6 because it's open right there. Okay, so y cannot equal negative 6. Okay, so if you were writing this more formally, you might write the set of all x such that x is less than 7. And the set of all y's such that y does not equal negative 6. So This is a more formal way of writing that domain and range. If this graph was turned 90 degrees clockwise, okay, so then it would look more like that. There's no vertical line that touches it twice, so now it would be a function. And it looks like the bottom would be a y equals 7. So the range would be greater than 7. The domain would be that x can't equal -6. That's if it was turned clockwise. Find f of x minus g of x and the domain. So I need a common denominator, which means I'm going to have to multiply this second one by x minus 10 over x minus 10. So I'm going to have my 2x plus 1 minus whatever I get when I distribute this, x squared, minus 10x, that's minus 20x, plus 100, all over x minus 10. I have to make sure that I apply this negative to everything in here. So I've got a negative x squared. Then I have 2x minus negative 20x. That's plus 22x. And 1 minus 100 is negative 99. When I add, subtract, multiply, or divide functions, my domain has to satisfy f of x, g of x, and my composition. Here, x cannot be 10, because 10 minus 10 is a 0 denominator. Here, there is no denominator or radical, so x can be anything. So for this one, x can't be 10. For this one, x can be all real numbers. And then here, once again, x cannot be 10. So to satisfy all three of these, the only restriction is x cannot equal 10. F of x times g of x and the domain. I can put this one over 1 if I want to, if that clarifies things for us, so we're multiplying fractions. And when I'm multiplying fractions, I multiply the numerators and the denominators. So I would distribute the 2x and the 1, and then I would do x minus 10 times 1. Now, in this case, though, let me just write that as one single fraction. 2x plus 1 times x minus 10. That's the numerator. X minus 10 times 1 is x minus 10. Now, typically, I would distribute everything in this numerator, or FOIL it, some people call it. But since these two factors are exactly the same, this is a case where I can just cancel those out. And I get 2x plus 1. Now, our domain has to satisfy f of x, g of x, and the composition. X can't be 10, x can be all reals, and x can be all reals. The only restriction was x can't be 10. Find f of g of x. So that's the same as writing it like this, which means we're doing f of g of x is x minus 10. So we're just taking this x minus 10 and plugging it in to f of x. So we get 3 times x minus 10 squared plus 2. X minus 10 squared means x minus 10 times x minus 10. And you can distribute that, or the shortcut, first term squared. The product of these is negative 10x. Double that is negative 20x. So first term squared, double the product. Then second term squared. Now we need to distribute the 3. right? And then we still have plus 2. So our like terms are 302, 3x squared minus 60x plus 302. This time we're finding the domain of g of f of x. Our inner function is f of x. So step 1, the domain of that inner function, f of x. F of x has a radical, and what's under a radical has to be greater than or equal to 0. Now if there was no radical here, it was just x minus 2, my domain would be reals. X has to be greater than or equal to 2, and I'm going to circle that because we use the inner function as part of our final domain. Step 2, the domain of the outer function. In this case, that's g of x. I've got a denominator here, and that denominator cannot equal 0. So x cannot equal 7. Okay, that tells me go on to a step 3. If that was all reals, I would be done. But since it's not, I go to step 3 and find the domain of the composition. And for that, I steal from step 1, f of x, and step 2 cannot equal 7. So the square root of x minus 2, that's f of x, cannot equal 7. So I square both sides. And move that 2 to the other side. And I circle that. My domain has to satisfy the inner function, f of x, that's what I circled here, and the composition, which is what I circled here. So the final domain, I'm going to write this in the formal way, domain of g of f of x is the set of all x, such that x is greater than or equal to 2, but x does not equal 51. So I've written a domain that satisfies the inner function and the composition of the functions. Graph the equation. For number 11, I would use the x and y intercepts. 6x minus 8 times 0, because where you're crossing the x-axis, the y value is 0. 8 times 0 is 0, so I get 6x equals 24, and when I divide by 6, I get x is 4. So I've got an x-intercept of 4. For the y-intercept, that's where the x has a value of 0. 6 times 0 is 0. Negative 8y equals 24. Divide by negative 8, and you get y equals negative 3. So to get from one to the other, it's up 3 and right 4. So I'm going to put more points on there to make sure I keep a good slope. And then I'll go down 3 and left 4. For number 12, it's in slope-intercept form, so I'll use my y-intercept of negative 1 and my slope of 5/3, up 5 and right 3. And I can go down 5 and left 3. And last, write an equation in slope-intercept form, and we will start from point-slope form, which is y minus y1 equals m times x minus x1. Here's my slope, that's m. Here's a point that the line is going through, that's x1 and y1. Y minus y1 is y minus 2. M is 5. X minus x1 is x minus 6. So now distribute. And then move that 2 to the other side. Negative 30 plus 2 is negative 28. So there it is in slope-intercept form. On 14, we have to find the slope. That's y minus y over x minus x. 4 minus negative 1 is 4 plus 1. 2 minus 5, negative 3. So the slope is negative 5/3. We can choose either point A or B as x1, y1. Typically, people like to stay away from the negative, so I'll do that. Y minus 4 equals negative 5/3 times x minus 2. So y minus 4 equals negative 5/3 x plus 10/3. That's 2 over 1. Negative times negative is positive. 5 times 2. 3 times 1. And last, I need to move that 4 to the other side. When I do that, I'm going to add it because it's minus. And I'm going to go ahead and get a common denominator. So 4, but it needs to have a denominator of 3. So I'm going to multiply 4 by 3/3. And that is 12/3. So we get y equals negative 5/3 x. And then 10/3 plus 12/3 is 22/3.